So we use the word bias a lot in class on Thursday when talking about things not going so well, especially in that political scientist example. But sampling bias refers specifically to this tendency to select people because of your sampling scheme. So the sampling in there is about the actual sampling scheme having some sort of problem. Um, in order to reduce sampling bias, there are some strategies. First is making things as random as possible. The more randomness there is, then the better our sample is going to be. So things like a stratified sample or a cluster sample or a systematic sample are actually less ideal than our SRS because our SRS is truly as random as it can get. The next thing we could do is pull more people. The larger our sample is, the more information we have, the better our estimation is going to be. There is, of course, the big caveat that bigger is not better if the sampling method is inherently biased from the beginning. Like we saw with the census. If we're leaving out people who don't have a permanent mailing address, it doesn't matter if we select more people. Or if we're doing the Literary Digest poll and we sample a gigantic, biggest sample ever done to make a guess who's going to win an election, but it turns out our sample is everybody who has the money to afford a telephone. Back in that day and age, we're not going to be getting a very accurate picture. It doesn't matter how many people we have. We're going to talk specifically about 3 types of sampling bias that are named here. You can see them. They all are exactly like what they sound like, so it's actually pretty easy for you. This is something that is 100% on the exam. There are usually 2 ways I ask this exam question. One is similar to a question that's in your homework about an airplane. I think it's like an airline that's trying to figure out seats for children, or something like that, like safety equipment for babies. I think that's what it was. And that's where I'm just going to describe a sampling situation or something that someone has done and ask you to just write about what's some potential issues with it. If I give you this type of question, I'm not looking for you to throw out definitions. You don't need to use the word undercoverage. In fact, I would much rather, instead of you just writing there's undercoverage, that you write, oh, well, they've left out this group. I don't care about the names there. I just want to see your critical thinking skills and the way you think like a statistician. The other way I ask this question is by giving you an example and asking you to identify which of these 3 types of bias is the most prominent. This is almost more challenging because you have to sort of turn your brain off and not think of all the other things that could happen and focus just on which one am I really prepping you for. So that's what we'll talk about. So the first type of sampling bias that's defined here is undercoverage, and that's when we leave people out. So our census example with the leaving out anyone who doesn't have a permanent mailing address, that's an example of undercoverage. Non-response, we saw that in our political scientist example. Sorry. The non-response bias, this is when she chose her sample of 250 people, but only 104 sent back the mailer. So there was a big problem with non-response there, which is going to bias our sample because there's something different about those people who didn't respond. The last one here is response bias. In response bias, this is when there's some reason that people are going to give us some misinformation, whether it's them and their behavior or something that we're doing as an interviewer that is influencing it. An example of that would be, I don't know, if I was walking around wearing a shirt for Core Power and asking people what their favorite yoga studio was, I might get more people. I'm priming them to think of that particular yoga studio. It was a terrible example. I'm very bad at thinking on my feet. But we'll see an example of each of these 3 on the next page anyways. To talk a little bit more about response bias, I've given you 2 examples here. Response bias can be subtle. It can be really in your face. But here's a subtle example. The way you word questions can actually change the responses that you get. So we have 2 here. One says, should the budget surplus be used on a tax cut or should it be spent on new government programs? The other one says, should it be used on a tax cut or should it be spent on programs for the education, environment, healthcare, crime fighting, and defense? I think all of us can immediately see which one of these is probably going to have a higher proportion of people saying, yeah, go ahead, government, keep my money. And that's going to be the second one because there's something to pull at each of our heartstrings. For me, I'll be like, oh yes, government, keep my money, spend it on education. It'll probably come back to me anyways. But this idea of just how you word a question can change how people are going to answer it. Additionally, there's studies that show you can flip the order of certain questions in surveys and drastically change the responses that you get in terms of how many people are responding positively to a question. So here comes the part where you guys do some work. We have our 3 types of bias. I'll go ahead and rewrite them here so that you don't have to go flipping back and forth. We had our undercoverage when we left people out. We had our non-response when we chose people and then they left themselves out. And we had our response when there was some reason that people may not answer truthfully or give us accurate information. So I want you to pause the video, try it out, read through these, and determine which of these am I trying to get you to see as the biggest source of bias. All right, so coming back, first one, we mailed a questionnaire, received responses from 23% of the people. As soon as you see something like this, 23%, I've given you a number. I've told you that people didn't respond. Nothing else matters here. You can sit there and argue that there's undercoverage because we left out some people who didn't respond. You can argue that there's a response because the people who responded are going to be the ones who didn't think it interfered on their workday. But none of that matters. In fact, the response bias is not a response bias. The people are telling us the accurate information. The fact that we are letting that people not respond who probably think that this is actually an encroachment on their workday is the bigger problem. So this is a non-response issue. And non-response is going to be pretty easy to spot if I do one of these types of questions on the exam because I have to give you numbers. I think there's only one time I've ever done it without numbers, and I think I just talked about like calling people during dinner or something, so it was a little more subtle. Number 2, we're going to conduct a survey. We're going to have teachers verbally administer this survey to sophomores, asking them about their drug use. Hopefully we can see here our issue is going to be response bias. There is a reason we're not going to get accurate information. Verbally administering a sensitive topic test is going to result in response bias. These students are not going to be truthful with their teachers about whether or not they're using drugs. All right. Next one. We're going to mail a questionnaire to 1,023 randomly selected households, and 15 questionnaires are returned. Again, we've been given a number. We have an absolute crap ton of non-response bias here. Yes, obviously, this is the most poorly set up survey in the world. We're asking people if they speak English as their primary language by sending them a questionnaire in English. But again, the biggest problem is going to be our non-response. That non-response is definitely fueled by the choice here, but that's our what I'm trying to get you guys to get to as your largest source of bias. The last one is going to be undercoverage. Undercoverage tends to be the hardest one to spot. It doesn't have the advantages of the other two in terms of like being a sensitive topic or having the number of people who responded. It usually is a little more work. You have to sit there and think about who's the population, what was the sample, and then see the disconnect. So here, if we look through here, we were told this group was interested in whether voters would support the lowering the drinking age. And then to figure this out, they went and randomly selected 25 students. So our population was voters and our sample was students. I'm not even going to bother with the numbers because it doesn't matter. We left out anybody who wasn't a student. And this is when there's always good discussion, if I do this in class, about like, well, the students are going to be the ones who want to lower the drinking age, so isn't this response bias? And again, the students are giving us their true information. It's accurate information. The problem of leaving everybody else out is that we're going to way overestimate the number of people who want us to lower the drinking age, because we're going to say everybody wants the drinking age lowered because a bunch of students said that, when in reality, those old folks like me are sitting there going, no, please. There's already too many of them at the bars. No. All right, so last question for this section. These last two little exercises. Again, pause the video, try them out. Welcome back. All right, so first one, hopefully you tried this on your own, because this is usually one of my favorite ones to do in class, because everybody has a different answer. And it's great. And I usually have you guys then try to convince each other, and people usually convince everybody in the wrong direction, and it's fabulous. So let's talk about what we have here. All 23 bird watchers at a randomly selected national park were asked if they saw any bluebirds. So first thing that distracts students, they'll see that randomly selected, and a lot of students immediately go, oh, that must be an SRS. No, not an SRS. An SRS would have every single bird watcher listed, and we would randomly select from that list of every single freaking bird watcher. So just because you see randomly selected, that does not mean you have an SRS. There's random selection still inside of a stratified and a cluster. The only one that doesn't really have the random selection part is that systematic, because we're using that system. The next biggest mistake is to think this is a convenient sample, because it is dang convenient that we went to one park only and then just talked to everyone there. So I can definitely 100% see the confusion. My argument for why it is not a convenient sample is that this is a randomly selected park. Since it is randomly selected, that does not mean it was the most convenient park, right? If I said I went to Mission Trails and asked people, or, oh, it's not a national park, but if I went to Yosemite or somewhere close and asked people, then I would be talking about convenient sampling, because I chose somewhere close to where I was. There was no random part to it, right? That's what happens with convenient sampling. So this actually is a cluster sample, because we randomly selected our group and then we chose all people in it, right? So our random selection is happening at the group level and we're choosing everyone. It is a really bad cluster sample is what it is. It is not stratified, because that would be taking a sample of a couple of bird watchers from every national park. And then 6, what can go wrong? This is a good one to look at just the wrong answers, because you'll see how I usually write my test questions. A lot of the questions from part 1 are multiple choice on the exam, which is why there's a lot of multiple choice in your homework as well. So what could go wrong with this particular sample? A says the bird watcher selected from a national park may create an unbiased sample. Problem here, really just that word. I mean, the fact that we have just one park is going to create a biased sample, right? If that one park is in a different part of the U.S., right, whatever part is going to make a big difference. B, the chosen national park may not accurately represent all national parks. That sounds like a problem, a representative problem. That does seem exactly like what we thought was wrong. Let's just keep reading. C, the national park is selected at random. The data is therefore relatively unreliable. Random is good. Random is not unreliable. And our last one, the sample size may be too large, which makes reading the data difficult. First off, 23 is not large. Second, even if it was 2,300, there's nothing wrong. Like, in the day and age of technology, there's no such thing as making the data difficult to read. So D is out. So that's everything about our bias for now. We got one more video, and then you're done with part 1.